Dear students, welcome to Maths Companion. I am Ramesh. Shall we start our study of mathematics? This year, you have so many interesting lessons which you can learn with fun. Let us learn one of them. Suppose I have to floor my room with tiles. How many tiles shall I buy? How can I find it out? I have to measure my room. What shall I measure? I need to measure the flooring area of my room, isn't it? Today, we are going to learn first part of our first lesson, area. Area is the space inside a shape. Consider a rectangle. The length is 4 cm and breadth is 3 cm. What is meant by the area of this rectangle? It is the space inside this rectangle. Let us try to understand the meaning of area. Consider a small square of side 1 cm. The area of this small square, that is the colored region, is 1 centimeter square. Now, in order to find the area of this rectangle, we are going to check how many small squares like this can be placed within this rectangle. Since the length is 4 centimeter, we can place 4 such squares on the length like this. 1, 2, 3, 4, right? Now, since the breadth is 3 centimeter, we can place 2 more such rows in this rectangle. This is one row of small squares. Again, we can place 2 more such rows like this. Now, what is the total number of small squares in this rectangle? 4 into 3, that is 12. And we know the area of one small square is 1 centimeter square. So the area of this rectangle is 12 centimeter square. That is why the area of the rectangle is length into breadth. Now, let us draw a rectangle of area 12 centimeter square. We have seen such a rectangle now. When the length is 4 and breadth is 3, the area is 12. Is it the only possible one? Let us check. What is the area of this rectangle? The length is 6 and breadth is 2. So the area is length into breadth or 12 centimeter square. What about this one? 12 into 1, again 12. So all these three have their area 12 centimeter square. Are there only 3 such rectangles? Let us check. We know area of a rectangle is length into breadth. So find out two numbers in such a way that their product is 12. Taking all those numbers as sides, we can draw a lot of rectangles with area 12 centimeter square. For example, 12 into 1 is 12, 6 into 2 is 12, 3 into 4 is 12. Again, you can take decimals and fractions. Half into 24 is 12, 1 by 4 into 48 is 12. So you can draw a lot of rectangles with area 12 centimeter square. Let us see. See the rectangles. All these rectangles have their area 12. Here the sides are 0.5 and 24. Now it is 0.75 and 16. The area remains unchanged. In all these cases, even though the sides are changing, the area remains unchanged. Now, you can take more examples by taking the values 0.1, 0.2, etc. So, all these are rectangles with area 12 centimeter square. So, what did we see? We can draw a lot of rectangles with area 12 centimeter square. Only thing is that we have to find two numbers whose product is 12. and we can take them as sides and we can draw the rectangles. Now suppose you are asked to draw a rectangle with area 12 centimeter square and one side 8 centimeter. Here there is one more condition. Area is 12 and one side is 8. Let the length be 8. Then we know length into breadth is the area. That is 8 into breadth is 12. So what is breadth? 12 by 8. Now let us simplify. 3 fours are 12 and 2 fours are 8. So that is equal to 3 by 2. And what is 3 by 2? 1.5 or 1.5. That means when length is 8, breadth should be 1.5. So there is one and only one rectangle where the length is 8 and area is 12 centimeter square. What did we see now? When area is given, we can draw a lot of rectangles with that area. But when area and one side is given, we can draw one and only one rectangle satisfying these two conditions. Now let us look at another problem. Here we have to draw a triangle of area 12 centimeter square. How can we find the area of a triangle? Area of a triangle equal to half BH, where B is any side and H is the height to that side. So let us check. What is the area of this triangle? Half into 4 into 6, that is 12. Again, here also the area is 12. Can we draw more triangles with area 12 centimeter square? Let us see. See these triangles. Everywhere the area is 12. Here the base is 2 and height is 12. Here the base is 2.5 and height is 9.6. In all these cases, the area is 12. You can see the area remains unchanged. The base and height are changing, but the area remains unchanged. That means you can draw a lot of triangles with a given area. Now what about this triangle? The base is 8 and height is 3. The area is half into 8 into 3. That is 12. So this is also a triangle having its area 12 centimeter square. What about this one? Here also the base is 8 and height is 3. So surely the area is 12 centimeter square. And in this case also the area is 12 centimeter square. In all these three, the bases are same and their heights are also same. Are they same triangles or equal triangles? No, you can see the shapes are different. Even though the bases and heights are same, the triangles are different. Now you can see the bases are same. So let me place one triangle over the other matching the bases like this. Here I have placed all the triangles one over the other, placing the bases exactly one over the other. So these are the bases of all the three triangles, and that is 8. Now this is the height of one triangle, this is the height of another triangle, this is the height of another triangle. Now let us observe the third vertices of the triangles. This is the third vertex of one triangle, this is the third vertex of the other triangle, this is the third vertex of the other triangle. What did we see? They are on a line. They are on the same line. And what is the speciality of this line? That is a line parallel to the base. See, the distance between the base and this line is 3 centimeter everywhere. So it is a line parallel to the base. That means when the base and area are same, the third vertices are on a line parallel to the base. Let us see this once again. Here I am going to take triangles with base 8 and area 12. Let us look at the third vertex E. Let me change it. Everywhere the area and base are same. So where is E? It is on the same line. In all these cases, the base remains unchanged and you can see the area is also remains unchanged. And you can draw a lot of triangles like this with same area and same height. And where is the third vertex? It is on this same line. And what is the speciality of this line? This is a line parallel to the base. So what did we see now? When we take the triangles with the same base and same area, their third vertices are on a line parallel to the base. And conversely, we can say when we take triangles with the same base and with third vertices on a line parallel to the base, then the triangles have same area. So this is one very important point which you have to write down in your notebook. All triangles with same base and area have the third vertices on a line parallel to the base. Conversely, all triangles with same base and the third vertex on a line parallel to the base have the same area. Remember, triangles with same area and same base. The third vertices are on a line parallel to the base. Now, when you take triangles with same base and third vertices on a line parallel to the base, the triangles will have same area. Now, let us do some problems. Draw a triangle of sides 4 cm, 5 cm and 6 cm. Draw an isosceles triangle with the same base and area. First of all, let us draw the triangle with sides 4 cm, 5 cm and 6 cm. For that, let me draw any one side. Here I am going to draw the side with length 4 cm. Now take 5 cm in the compass and draw an arc from one end of this line. Now the third side is 6 cm. Take 6 cm in the compass and draw an arc from the other end of the line. Now mark the point of intersection. This is the third vertex of the triangle. Join the point of intersection to the ends of the first line. So now we got the triangle with sides 4 cm, 5 cm and 6 cm. Now we have to draw an isosceles triangle with same base and area. So there are two conditions. First of all, it should be an isosceles triangle, and secondly, it should have the same base and same area of this triangle. How can we draw an isosceles triangle? In 8th standard, we have studied that the third vertex of an isosceles triangle is always on the perpendicular bisector of the base. So let us draw the perpendicular bisector of the base now. How can we draw the perpendicular bisector? For that, take your compass and take more than half of the baseline, that is the 4 cm line, and draw arcs on both sides of the line. Now put the compass on the other end of the baseline and without changing the radius, again draw arcs on both sides of the baseline. Now mark the points of intersection and join them. This is the perpendicular bisector of the base. Now if you mark a point anywhere on this line and join that point to the ends of the base, you will get an isosceles triangle. But we need an isosceles triangle having the same base and area of this given triangle. How can we make a triangle with same area? We know the triangle with same base and third vertex on a line parallel to the base will have same area. So let us first draw a line parallel to the base passing through the third vertex of the given triangle. How can we draw a line parallel to the base? For that we need our set square and our ruler. Now place the set square on the line like this and hold it firmly. Now place the ruler next to the set square like this. Now hold the ruler firmly and slide the set square along the ruler like this. Slide it till it reaches the third vertex of the first triangle. Now draw a line through the point. So that is the line parallel to the base. Now let us change our set square and ruler. Now we can see the line parallel to the base. Now you can take any point on this line. If you join that to the ends of the base, we will get a triangle with same base and area. If you join the ends of the base to a point on this line, you will get an isosceles triangle. We need both. So we have to take the point of intersection of these two lines. Now join this point to the ends of the base. Now we got a new triangle. It's an isosceles triangle because the third vertex is on the perpendicular bisector of the base. It has the same area of the first triangle because it has the same base, and the third vertices are on a line parallel to the base. So this is the required triangle. Now another problem. Draw a triangle of sides 4 cm, 5 cm and 6 cm. Draw an isosceles triangle with the same area and base 5 cm. Same triangle, only difference is that we have to make an isosceles triangle with base 5 cm. First of all, we have to draw the triangle, and you know how to draw the triangle. We have already drawn it. Now we have to make an isosceles triangle with the base 5 cm and having the same area of this triangle. So we know in order to make an isosceles triangle, we need to construct the perpendicular bisector of the base. Here we are going to take the base as the side with 5 cm. So let us draw the perpendicular bisector of this line. For that, we can take more than half of the length as radius and draw arcs on both sides. Now put the compass at the other end and taking the same radius, draw arcs on both sides. Mark the points of intersection, join them, we will get the perpendicular bisector of that side. Take any point on this perpendicular bisector, join that to the end points of this side, we will get an isosceles triangle. Now we need an isosceles triangle having the same area of this triangle. For that, let us draw a line parallel to this line passing through this point. For that, let us take the set square and ruler. Now place the set square on this line like this. Place the ruler next to it like this. Now hold the ruler firmly and slide the set square along the ruler. Now draw a line through this point. This is the line parallel to the base. Now let us mark the point of intersection of these two lines. Now let us join this point to the ends of the 5 cm side. So this is the required triangle. The base is 5 cm. It's an isosceles triangle because the third vertex is on the perpendicular bisector of this side, and the area of this triangle is equal to the area of the first triangle because the bases are same and the third vertices are on a line parallel to the base. Just like this, you can make triangle with same area by taking the third side also. Now another problem. Draw a triangle of sides 4 cm, 5 cm and 6 cm. Draw a triangle of the same base and area with the left side 7 cm. Same triangle, but here we have to draw a triangle with the same base and area and with left side 7 cm. First of all, we have to draw the triangle with sides 4 cm, 5 cm and 6 cm. And we have already seen how to draw the triangle. Draw one side. I have drawn the side with length 4 cm. Take 5 cm in the compass and draw an arc from one end. Take 6 cm and draw an arc from the other end. Mark the point of intersection and join that to the base. So we got the required triangle. Now we have to draw a triangle with same base and area and with the left side 7 cm. We know if you have to draw a triangle with the same base and area, the third vertices must be on a line parallel to the base. So first of all, let us draw a line parallel to the base. Take our set square and ruler. Now place the set square on the base like this. Hold it firmly. Now place the ruler next to the set square like this. Now hold the ruler firmly and slide the set square along the ruler like this. Slide it till it reaches the point. Now draw the line through the third vertex. So we got the parallel line now. Now if you mark a point anywhere on this line and join that point to the ends of the base, we'll get a triangle with same base and same area. But we need the left side 7 cm. How can you make it? Now take 7 cm in the compass and put the compass at the left end of the base. Now draw an arc to meet the parallel line like this. Now mark the point of intersection, join it. The length of this line is 7 cm. Now join the point of intersection to the other end. So we got a triangle now. The left side is 7 cm and it has the same base and area of the given triangle because the third vertices are on a line parallel to the base. Now let us do some problems from page number 11 and 12 of your textbook. First problem, draw a triangle of sides 3, 4 and 6 centimeters. Draw three different right triangles of the same area. First of all, let us draw the triangle with sides 3, 4 and 6 centimeters. Draw a line of 3 centimeter at first. Take 4 centimeter in the compass and draw an arc from one end of the line. Now take 6 centimeter in the compass and draw an arc from the other end. Mark the point of intersection. Join that to the ends of the first line. So we got the triangle with sides 3, 4 and 6 centimeters. Now we have to draw three different right triangles of the same area. We know if we want to draw a triangle with the same area, we have to keep the base same and the third vertex should be on a line parallel to the base. So first of all, let us draw a line parallel to the 3 centimeter side. You know how to draw a line parallel to a side using set square and ruler. Place the protractor like this on the line. Now place the ruler like this. Hold the ruler firmly and slide the set square. Now draw a line through the third vertex. Now we have to draw three right triangles of the same area. Let me take 90 degree at one end of the 3 centimeter side and draw a line. Mark the point of intersection of this line with the parallel line. Now join that point of intersection to the other end of the base. This is the required triangle. It's a right angle because this angle is 90 degree and the area of this triangle is equal to the first triangle because the base is same and the third vertices are on a line parallel to the base. Now let us draw the second right triangle. For that let us take the triangle at first, the triangle with sides 3, 4 and 6 centimeter. Now I am going to draw a right triangle with 6 centimeter side as base. Take the set square and ruler, place it like this. Now place the ruler next to it. Now keep the ruler firmly and slide this square till it reaches this point. Now draw a line through that point. So this is the line parallel to the 6 centimeter side. Now from one end of this side, let me take 90 degree angle and draw a line. Mark the point of intersection of this line with the parallel line. Now join that point to the other vertex of the 6 centimeter side. This is the required right triangle. It's a right triangle because this angle is 90 degree and the area of this triangle is equal to the first triangle because both of them have same base and the third vertices are on a line parallel to the base. Now let us draw the third right triangle. First of all, let us take our triangle with sides 3, 4, 6 centimeters. Now I am going to take this side as the base. So take the set square and ruler and place it on the line like this. Hold the ruler firmly and slide the set square till it reaches this point. Now draw a line through that point. So this is the line parallel to the 4 centimeter side. Now from one end of the 4 centimeter side, take 90 degree and draw a line. Mark the point of intersection. Join that point to the other end of the 4 centimeter side. So this is the third right triangle. It's a right triangle because we know it is 90 degree and the area is same because the bases are same and third vertices are on a line parallel to the base. Second problem. Draw the triangle shown below in your notebook. Draw triangles ABP, BCQ and CAR of the same area with measurements given below. Angle BAP equal to 90 degree, angle BCQ equal to 60 degree, angle ACR equal to 30 degree. First of all, let us draw triangle ABC. For that, draw a line of length 7 centimeter. Now take 60 degree at A and draw a line. Now mark the point C 5 centimeter away from A. Now join BC. So we got the triangle ABC. Now we have to make triangle ABP in which angle BAP equal to 90 degree and its area should be equal to the area of this triangle ABC. So first of all, let us make angle BAP. Angle BAP equal to 90 degree. So at A, let us take 90 degree and draw a line. Now we need a triangle ABP whose area is equal to the area of triangle ABC. So let us draw a line parallel to the side AB passing through the point C. So let us take the set square and take the ruler, slide it till it reaches C. Now draw a line through the point C, that is the line parallel to AB. Now mark the point of intersection of this parallel line and the line through A. Join B to P we will get the required triangle. In this triangle, angle BAP equal to 90 degree and area of this triangle is equal to the area of the first triangle, as the bases are same and third vertices are on a line parallel to the base. Now we need to draw triangle BCQ with angle BCQ 60 degree. First of all, let us draw the figure once again. Now given that angle BCQ equal to 60 degree. So take 60 degree at C and draw a line. Now to make the triangle having the same area of the given triangle, let us draw a line parallel to the side BC. Let us take ruler and set square and slide the set square till it reaches the point A. Now draw a line through the point A. Now mark the point of intersection of this parallel line and the line through C. Join it to B. This is the required triangle. This angle is 60 degree and the area of the triangle is equal to the area of the first triangle, as the bases are same and the third vertices are on a line parallel to the base. Now let us draw the triangle CAR with angle ACR equal to 30 degree. Let us take the first triangle ABC. Now given that angle ACR equal to 30 degree. So place the protractor at C and measure 30 degree and draw a line. Now we have to draw a triangle having the same area of the triangle ABC. So let us draw a line parallel to AC passing through B. Let us use our set square and ruler and place it like this. Now slide the set square along the ruler till it reaches B. Now draw a line through B. It is parallel to AC. Now mark the point of intersection and join it to A. So this is the required triangle ACR. The angle at C is 30 degree and the area of this triangle is equal to the first area of the first triangle, as the bases are same and the third vertices are on a line parallel to the base AC. Third problem. Draw a circle and triangle with one vertex at the center of the circle and the other two on the circle. Draw another triangle of the same area with all three vertices on the circle. First of all, let us draw a circle. Now let us draw a triangle in such a way that one vertex is the center of the circle and other two vertices are on the circle, like this. Now we have to draw another triangle of the same area with all the three vertices are on the circle. So let us draw a line parallel to the base BC through the point A. For that, let us take the set square and ruler. Place it like this. Now slide it along the ruler. Now draw a line through A. This is a line parallel to the base. Let us mark the point of intersection, any one point of intersection. Now join the ends B and C of the base to this point to get the required triangle. In this triangle, all the three vertices are points on the circle, and the area of this triangle is equal to the area of the first triangle, as the bases are same and the third vertices are on a line parallel to the base. Fourth problem. How many different triangles can you draw with two sides 8 and 6 centimeters and area 12 square centimeters? What if the area is to be 24 square centimeters? Let us look at the first part. Here the area is 12 square centimeters. That is half into B into H is 12. Then what is B into H? 24. Let me take the base as 8. So draw a line of length 8 centimeter. Now height is 3 because 8 into 3 is 24. So take 90 degree at one end and draw a line. Now mark a point C 3 centimeter away from one end of the baseline. Now draw a line parallel to the baseline through the point C. For that, let us take the set square and ruler. Place it like this. Slide the set square along the ruler. Now draw a line through the point C. So we got a line parallel to the 8 centimeter line, which is 3 centimeter away from the baseline. Now we have to draw the triangles with sides 8 and 6. So take 6 centimeter in the compass and draw a circle from this end point. Mark the points of intersection of the circle with the parallel line. Now join these points to the ends of the base to get the required triangles. So there are two different triangles with area 12 square centimeters and sides 8 and 6 centimeters. Here the bases are same and the radius of the circle is 6. So these two sides are equal. So the triangles have the sides 8 and 6 and they have the same area as they have the same base, and the third vertices are on the line parallel to the base. So both of them have the same area 12 centimeter square. What about the triangle with area 24 centimeter square? When area is 24, half BH is 24. So B into H is 48. If you take base as 8, 8 into 6 is 48. So height should be 6. For our triangle, the side should be 8 and 6. So we can draw one and only one triangle. Take the base as 8, take 90 degree and take 6 centimeter. Now join it. We'll get the required triangle. Here the height is 6, which is one side of the triangle. So we can draw only one such triangle, which is a right angled triangle. Now let us remember what we have learned today. We have seen that generally when the area is given, we can draw a lot of rectangles with that area. But when area and one side is given, we can draw one and only one rectangle. Similarly, when the area is given, we can draw a lot of triangles with that area. Again, when the area and one side is given, we can draw a lot of triangles. After that, we have seen that all triangles with the same base and area have the third vertices on a line parallel to the base. Conversely, all triangles with the same base and the third vertex on a line parallel to the base have the same area. Now you have two assignments. First one, the fifth problem from page 12, and second one, the sixth problem from page 12. Hope you have understood. Do the problems and we will discuss it in the next video. I'll be back with another video. Till then, bye.